ASU researchers are working to create a plant-based plastic that would be safer for public use and also be easier to recycle. Currently, only 14% of plastic is recycled, and some plastics contain chemicals that are harmful to humans. Joining us now is Matt Green. He's with ASU School for Engineering and Matter and Transport and Energy and all that kind of stuff. Good to see you. Thanks for joining us.
Thanks so much for having me.
All right, this focuses on something called BPA, and I think we've all kind of heard of it, but we're not sure what it is. What is it?
BPA is a small molecule. That acronym stands for bisphenol A. It's a common precursor used to make, or used to be a common precursor to make a whole lot of products that we would use and find on the shelves.
And is it still being used for those products?
For the most part, it's been phased out. We've found some alternatives, and some companies had some things ready to go. And the issue was that it could disrupt some of the hormone functions in small children and basically an endocrine disruptor.
Interesting. How dangerous was that? How dangerous is this stuff?
Well, the concern was developmental, so it's not like there would be an acute effect. It's the long-term chronic exposure that could cause developmental issues.
Heart disease, cancer, infertility, all those things are listed here.
Right.
So the BPA, how do you, like now, how do I know if something has BPA, or do I know?
So a lot of the common plastics that had BPA as a component are now labeled as BPA free, and so you can see that as labeling.
Yeah.
And there for a while it became a big marketing ploy to be able to say our materials are free of BPA.
Yeah, provided they are free of BPA.
Right. Yeah.
All right. You're developing a plant-based plastic that leaves BPA way behind, but what is this all about?
So the idea was, I was visiting the University of Delaware and talking with colleagues there, and they had developed this process to convert lignin, which is a byproduct of paper making and the whole wood processing, that industry. And they could take these lignin materials and then make a whole diversity, a whole array of chemistry and chemicals from those byproducts, from those waste materials.
How does that done?
You'd have to talk to them. It's not straightforward.
Yeah.
And the beauty of it, right? Natural materials are very complex. And so when you begin breaking these down into small molecules, into their components, it'd be like smashing a Lego castle, right?
Wow.
You can pick up all these different pieces. And so the question is, what can you do with all those components? So one of them we found looked an awful lot like bisphenol A, aside from the fact that it had a couple of other additional functionalities that nature provides. And through some investigation, we found that actually prevents that bad endocrine disruption property that bisphenol A exhibits. So they turned out to be safer.
So basically, you're talking about wood waste. Essentially, wood waste is now plastic.
That's right.
Okay, what kind of plastic? Is it as tough as plastic? What are we dealing with here?
So what we made was this class of material called polysulfones, which are really tough. NASA's used these for a long time. They're used in the underlayments of membranes that purify water. So they're used for some really tough environments. And we were able to take this lignin-derived bisphenol A replacement and make some of those same membrane-forming materials.
It feels like plastics are forever. Is this forever?
Well, so the idea is that we can design these to be safer, to also be recyclable. And so the whole plastic industry now is really kind of rethinking what we want our legacy to be.
Yeah.
And so there's so many concerns about human health, environmental health, and also sustainability.
Is it the kind of thing that can be produced, though, on a mass scale?
Absolutely. Yeah. So the paper industry, right, the wood processing
Yes.
industry is quite large.
So I would imagine that to recycle this, what do you do? When it's recycled, does it become that wood waste again, or does it become something else?
It would become something else, yeah. So in the process of going from wood waste to this membrane that we
Yes.
could use to treat water, we do an awful lot of, there are quite a few steps involved in that. In terms of, we get these small molecules and we can turn those back into polymers, which are these long molecular chains.
Interesting. And you mentioned water a lot. That's a big deal here, isn't it?
Yeah, it sure is. Yeah, we think about it, we worry about it, It's part of our DNA here.
Yeah, but in terms of this plastic, this new kind of plastic, it improves water. You kind of referred to this earlier, but I need clarification on that.
Yeah, so some of those functional handles that nature
Yes.
provides, that puts onto this molecule for us, actually make it so that we can purify more water. We can push more water through. And so it's a property called hydrophilicity, and it allows us to purify water more energy in a more energy efficient manner, and higher volumes of water too.
And all kinds of purification, everything from what? From municipal areas to what? What's in your backyard?
Yeah, these materials specifically do well at removing things like bacteria and other large impurities in water streams. Yeah.
And with that, I read that they could be used in medical devices like dialysis machines.
That's right. These polysulfones, this class of material is also commonly used for doing that.
Okay, so the bottom line is you got something here replacing plastics, and it seems like it's on the go. Is this out there right now? Are these products out there? If not, when?
So we've patented this, and we're now working on trying to improve that technology and scale it up.
Okay, so that's on the move. I got to ask you, because it's the same obvious question here. The government cutbacks of funding and research and these is that affecting you?
Absolutely, yeah. In many ways, largely the uncertainty right now, at least in my field specifically, is not knowing what's coming. We're days away from inking contracts on new projects that are still on hold.
Yeah.
And we don't know if those will come back, and we certainly don't know what new funding opportunities are going to look like. So in the words of President Crow, we're widening our aperture. We're looking at being number one in innovation here at ASU. Right?
Yeah.
We're getting creative in how we can continue to do research and support our students and our communities. Right? These technologies are not for us. It's not for our glory. We're out here trying to make the world a better place for the people around us.
New avenues of innovation if you have to.
That's right.
All right, Matt Green, ASU. This is really interesting stuff. Thanks for sharing. We appreciate it.
Thanks for having me.